Hi everyone. So let's discuss divisibility rules. Now, what is divisibility rule? For example, if I have to find out whether, let's say some number 7056, is it divisible by 14 or not? So one way how to find a given number, let's say 7056 is divisible by a particular integer, 14 or not, we all know that. Take the long division method and see if it is divisible or not. If it doesn't leave any remainder, if remainder is 0, then it is divisible, right? Remainder is not 0, then it is not divisible. Simple as that. So the basic rule is you try, if it is for smaller numbers, you try and do the long division method. But let's say if you have to solve something like this, check whether 9 divides this number. So if we try, or rather I would like you guys to pause the video and try and see how much time will it take, right? So 51, 9 5s, 45, left with 6, 68, 9 7s, 63, 5 remains, then 4 comes, then 4 is directly, 6 is there, right? So 54, we have 0, so 2 will come and 7 will come, so I'll need to add a 0 because there is one more 0, and 3, 9 3s are. So the answer is yes. Check whether the answer is yes. But then this can be, instead of 9, if something else is given, let's say some 121 is given, okay? What happens is essentially they can be time consuming basis the numbers, okay? So that's why we will be looking at some basic rules, okay, that will help us cut down a lot of time. Make sure you all write this. So these digits are good enough to know. This will include most of the questions that will be asked in the exam. How do you know whether a digit is divisible by 2? Obviously, the last digit must be divisible by 2, or it should be an even number, basically, right? Yes. If the last digit is divisible by 2, yes, 8 is divisible by 2 and 0 is divisible by 2. 0 is divisible by any number because 0 is universal multiple, we have discussed. That is about 2. 3 is sum of the digits must be divisible by 3. Now, what do they mean by that? Now, let's say 972, right? Sum of the digits, 9 plus 7 plus 2, which is 16 plus 2, 18. The sum of the digits must be divisible by 3. Same for 2304, 2 plus 3 plus 0 plus 4, which is 9. So yes, 9 is divisible by 3. So this is divisible by 3. So 3 and 9 are similar. Remember, sum of digits must be divisible by 3 and sum of digits must be divisible by 9. So 972 we have seen above, the sum is 18. Is it divisible by 9? Yes, the answer is. And for 2304, the sum is 9. Is it divisible by 9? Absolutely. So 3 and 9 are similar, okay? Now 4 is the way, for 2 it's the last digit, for 4 it is the last 2 digits of a number, okay? What are the last 2 digits of 568? 68. I'll need to see whether 68 is divisible by 4 or not, right? 4 ones are 4, 28, 4 sevens are 28. Yes, the remainder is 0, that means it's completely divisible. So is with this 04. Of course, 04 is divisible by 4. There's no remainder. So that is how you will know whether a given number is divisible by 4. Last 2 digits. 5 is pretty obvious. You just look at the last digit. If it is 5 or 0, then they are divisible. Straightforward. 5 and 10 are straightforward. Now, for 6, there is no special rule. If a number has to be divisible by 6, of course it must be even and it must be divisible by 3. Okay. So that means a number must be divisible by 2 as well as 3. Then we can say it is divisible by 6. So 972 we have seen divisible by 3 and it's an even number, so it's divisible by 6. Same for 2304. The number is divisible by 3 and it's an even number, so it's divisible by 6. So for 6, you just need to see even number divisible by 3 or not. Now 2, 4 and 8, which is 2 power 1, 2 power 2, 2 power 3 have a weird coincidence, of the rules. 2, it's the last one digit. 4, it's last two digits, and 8, which is 2 cube, is last three digits. Okay, you can remember in that way. So for 68, since it is itself is a 3-digit number, I'll need to do it normally. So 8 sevens are 56 and 0 is there, 8 comes, so this is divisible. Same for 2304, what do I need to do? I just need to do 304, the last three digits, right? 8 threes are 24. What remains? 6 remains and 4 comes. 8 8s are 64, right? So there is no remainder. That means completely divisible. So both of these are divisible by 8. 9 we have seen, and the last one is 11. It's tough to understand by the wordings. Difference of sum of alternate digits of a number. Sum of alternate digits, first you find out and then take a difference. Now what do they mean by that? Begin with the first digit, the alternate digits sum. Okay, so first you will find sum of this. So I have 15, then you check the other alternate digits. These are the next alternate digits. What is their sum? 4, and the difference of these two must be divisible by 11. Yes. Same for 484. Sum of alternate digits, 4 plus 4. Always start with the first digit, left. From left, the first digit. And the only digit remaining is 8. So the difference is 0. 0 is a universal multiple. So it is 0 divides any number. Okay, so 2, 4 and 8, last digit, last two digits, last three digits. 3 and 9, sum must be divisible by 3 and 9 respectively. 6, nothing to do, even number divisible by 3, and remaining is 5, which is straightforward. The only thing is 11. You start with the leftmost number, take the sum of alternate numbers and the remaining sum of alternate numbers and take the difference and check whether the difference is divisible by 11 or not. Okay, so check the divisibility of 2, 3, 4, 6, 8, 9 and 11. Okay, so let's write 2, 3, 4, 6, 8, 9, 11. So it's an odd digit, no even will be divisible. Eliminate straightforward. For 3, what is the sum? 9 plus 8 plus 0 plus 1. So 8 plus 1 is 9, plus 9, 18. 18 is divisible by 3 and as well as by 9, right? Now 6 is not possible because it has to be an even number. What remains is 11. So from leftmost you take the sum and save the remaining alternate digits, which is 9. Yeah, so the difference is 0, which is divisible by 11. So straightforward, the same. 2, 3, 4, 6, 8, 9 and 11. 2, definitely the last digit. 3, let us take the sum. 7 plus 7, 14 plus 8, which is 26. 26 is not divisible by 3. So if it's not divisible by 3, it's not divisible by any of its multiples. Okay, so we can eliminate 6 and 9 directly. Now for 4, we need to check the last two digits. Yes, obviously it's divisible by 4. For 8, 744. 8 9s are 72. I have 2 remaining. 4 comes down. 8 3s 24. Yes, it is divisible. For 11, sum of alternate digits starting with the leftmost. As you can see, they are giving the same value. 11 and 11, and the difference is 0, which is divisible. So that means this 7744 is divisible by 11. I hope the divisibility rules are clear. How to check? Okay. So I want to discuss something. Let's say if they ask you to find something beyond 11, let's say for higher numbers, if you have to find divisibility of something like 24 or 36 or 32 and so on and so forth, right? Now there are no rules to find for this, but if some number has to be divisible by 24, it has to be divisible by factors of 24. That is for sure, isn't it? If a number has to be divisible by 24, it has to be divisible by its factors, right? So for, let's say, we know that 48 is divisible by 24. But 48, for this, we don't have rule. So better is, what are the divisors of 24? 2, 3, 4, 6, 8, 12, 24, and so on. And we can start with 1. Now, what we'll need to do is, rather than testing this, you just see what we have learned. Up to 11, whatever is there, you try and check divisibility with these and try to get the answer. That is good enough. And the questions will be framed in such a way that checking with this will 100% give you the answers. Okay. So this is how the exam will try and test for the higher number. Okay. Divisibility of higher integers. So we'll see a question on this. If a certain project takes n whole days to complete, means n complete days, which of the following could be a number of the number of hours? Okay, remember, one day will have 24 hours. Okay, so total number of hours to complete this project would be 24 into n, right? N whole days, so 24 into n number of hours could be. So that means the options have to be divisible by 24. Now we have seen, to check for 24, what we'll do, we'll just take its up till here. So 12 and 24 will let it be. Now it has to be even for sure. Definitely what can we do is we can let go of all the odd numbers. So these two can never be true. Then we'll see, is it divisible by 2, the remaining? Yes. So this is of no use. Now check for 3. So I'll check for all the B, C and E. So 2 plus 1 plus 4. The sum is 7. This is not divisible by 3. It has to be divisible by 3. It has to be, if a number divides 24, it has to divide all of this, right? So same, let's check for 576. 5 plus 7, 12 plus 6, 18. It is divisible. All the 6s, yes, it is divisible by 3. So 3 is done. Now let's see 4. 4 is the last two digits, 76. Now 76 by 4, so 4 ones are 4, 36, 4 nines, 36. So this is divisible. Let us check 66. So what we are trying to do is we are trying to eliminate. Okay. 4 ones are 4 and 26. Okay, this is not divisible. 4 6 are 24, so we are left with 2. This is not divisible, so the only answer is C, option C. So this is how for higher number, let's say greater than 11, you can use this divisors concept. Okay, the next one, find the value of x if this number, so x is one of the digits. It's not a multiplication symbol. Don't get confused. This is x. If this is divisible by 11. Now, what is the rule? Divisibility rule of 11. Take the alternate. Sum of the alternate digits must be, difference of sum of alternate must be divisible by 11. So first sum we are going to take is 5 plus 2 plus 5 plus 2 plus 7. So 5 and 5, 10, 2 and 2, 4, 14 plus 20, 14 plus 7 is 21. The sum of the other, okay, this is 8 plus 1 plus x plus 3. So 9 plus 3, 12 plus x. So the sum of the difference of this, right? So the difference I can take either ways. Minus 21, this has to be a multiple of 11, which is x minus 9 should be multiple of 11. So let us put all the options. X minus 9, when x is 9, so this is going to be 0. Yes, this is the correct answer. We'll check for others. When x is 9, we get negative 1. No. C, 7 minus 9, negative 2. No. D, 6 minus 9, negative 3. No. E is also no. So A is the correct answer. So using the divisibility rules, we can get the answers quite straightforward and save a lot of time in the exam. Okay, so that's about it. I hope the divisibility rules are clear, and I'll see you in the next video. Thank you so much.